Number 1. Of the light bulbs available at a store, 42% are fluorescent, 23% are labeled as long life, and 12% are both. So we should probably make a Venn diagram to represent these probabilities, because this would be much easier than making a two-way table. So we have fluorescent, which I'm going to label the event F, and long life as the event L. So 12% are both of them, so point 12 goes in the middle of my Venn diagram. This entire F circle is 0.42. I already used up 0.12 of them, so 30% are fluorescent but not long life. They're just fluorescents. They're in that little crescent of the circle there. Well, 23% are long life. That whole circle there is 0.23. I used up 12 of it. I used up 12 of that 23%, so I'm left with 11% are just long life. They're not fluorescent, they're just long life. Well, what about the light bulbs that are not fluorescent and not long life? What about the the light bulbs that are not fluorescent, not both, and not long life? Well, together, that probability is 0.53, or 0.53 if you're one of them. So 0.53 is the circles and the overlap. So if I subtract that from 1, that gives me the non. So 0.47 is the outside. They're not fluorescent, they're not long life. Don't forget to do that outside box probability, the ones that are not fluorescent and not long life. A light bulb is selected at random from the light bulbs in the store. Rounding your answer to the nearest thousandth, so 3 decimal places, find the probabilities. The selected light bulb is not fluorescent, so what's the probability of not fluorescent, or the complement of fluorescent? Well, fluorescent is 42%, so 1 minus 42% is 1 minus 0.42, gives you 0.58. That's 58%. The selected light bulb is fluorescent given that it's labeled as long life. So we're given that it's long life. We have more information. So this is the probability of fluorescent given that it's long life. So our world has shrunk down to only looking at the ones that are labeled as long life. So if I go back to my Venn diagram here, the only ones that I want to look at are the ones that are labeled long life. I only want to look at light bulbs that come from this circle here. So my universe has shrunk down to 0.23. So that goes in the denominator when I compute this probability. I'm given L, so my universe shrunk down to 0.23. Conditional probabilities are and over given. What's the and probability? What fraction of the long life ones are also fluorescent? Well, that's 0.12 goes up top. That quotient, 0.12 divided by 0.23, is approximately 0.5 to, I'm going to round up to 2, because it's set to the nearest thousandth. Are the events fluorescent and long life independent of each other? Does knowing it's fluorescent or knowing it's long life affect the probability of picking the other one? So we already computed this conditional probability. We already found P of F given L. Let's use that. What am I going to compare that with? I'm going to compare that with P of F. So what's the probability of fluorescent? I think we know that is 0.42. The probability of fluorescence, 0.42. Knowing that it's long life, what's the probability I pick a fluorescent? 0.522. So are they independent? No, they are independent. Because, why are they independent? Because P of F does not equal the P of F given L. So knowing that extra information, the probability changed. They're no longer equal. So there was some effect of knowing that it's long life on the probability of picking a fluorescent. So they are not independent events. If those two numbers were the same, they would be independent. Big idea that you need to know how to determine if two events are independent. Josie will soon be taking exams in math and Spanish. She estimates that the probability she passes math is 0.9. So the probability of math is 0.9. The probability that she passes Spanish is 0.8. The probability of S equals 0.8. She's also willing to assume that the results of the two exams are independent. So because I know they're independent, I can find the probability that she passes math and Spanish. The probability of math and Spanish, well, because we assume that they're independent, all we have to do is multiply those probabilities together. All we have to do is multiply those two probabilities together. So the AND probability is 0.72. Create a Venn diagram where M is the event passing math and S is the event passing Spanish. So let's make our Venn diagram. That's math, that's Spanish, and because we assumed that they're independent, I know that AND probability is 0.72. The entire math circle is 0.9. The entire Spanish circle is 0.8. So what am I left with for this crescent here? Well, that has to be 0.08, 8%, and this is 18%, because I need that to add up to 90%. Are the events M and S mutually exclusive? Well, are they mutually exclusive? Mutually exclusive means they share no outcomes in common. So the answer is clearly no. They share... both events can happen. Let's write that. No, both events can happen. Mutually exclusive means only one event can happen. So, because there's that overlapping region there, both events can happen. Number 3, if events are independent, can they be mutually exclusive? So, if we assume that events are independent, can they also be mutually exclusive? Well, independent means knowing the probability of one doesn't affect the probability of another one occurring. So, knowing the probability of something already happening doesn't change the probability of another event. Mutually exclusive means both of them can't happen at the same time. Well, if you're independent, for an event to be independent, they both have to happen at the same time. Both events have to occur. Let's write that. For both events have to occur. For something to be independent, there has to be some overlap in your Venn diagrams. Both events must occur. Well, if both events must occur, can they be mutually exclusive? Therefore, the events cannot be mutually exclusive. They cannot be disjoint. Because if we think back to our fluorescent light bulb question here, to compute this conditional probability, that was our AND probability right there. We got that part of our conditional probability from the AND probability. So for them to be independent, there needs to be that AND probability. That AND probability cannot be 0, otherwise they won't be independent. So that AND probability, that overlap has to occur for two events to be independent. Sorry, that AND probability must occur for them to be independent, so they can't be mutually exclusive. Mutually exclusive, you have to know that diagram in your head. There's no overlap in the circles. Independent, they are overlapped. They just overlap in a particular way, so that knowing the probability of one event doesn't change the probability of the other event from occurring. That's lesson 6.